cycle is taking place in the stroma. That's where all the enzymes for the Calvin cycle are located. And we're going to use the ATP and the NADPH that we made in the light reactions. So CO2 comes in through the stomata of the leaf. Immediately, an enzyme Rubisco is there in the stroma. And the job of Rubisco is to take RUBP, which is a 5-carbon compound, combine it with CO2, which is a 1-carbon compound, and we're going to make, like, for an instant, we're going to make a 6-carbon compound, but that's very unstable, so we're going to end up with 2 3-carbon compounds, which we call PGA. PGA is then reduced to form PGAL. What do you guys think can reduce PGA? Well, our reducing agent is NADPH. It's brought electrons from the light reaction. So NADPH comes in, it gives its electrons, and what is released is NADP+, which can go back and be used in the light reactions again. PGA, some of this leaves and becomes sugar.
Wait, so electrons leave?
Well, so the difference between PGA, which is phosphoglycerate, and PGAL, which is phosphoglyceraldehyde, is this is the reduced form of this. So when PGA takes on electrons and hydrogen ions, it becomes PGAL. The PGAL that's left has to be rearranged into RUBP, and we need energy for the rearrangement, so we get the energy in the form of ATP, which gives us energy, and we end up with ADP, which goes back to the light reactions. So this goes back to the light reactions. This goes back to the light-dependent reactions. And what did we end up with? We ended up with sugar, okay? We started with CO2. So that's what the Calvin cycle is. It's a way of taking inorganic carbon in the form of CO2 and turning it into a storable organic carbon energy source, which we know is sugar. So when we named these steps, we named this carbon fixation. We named this reduction. And we named this rearrangement. Okay, so those are the 3 main steps of the Calvin cycle. And this is true for a C3 plant. A C4 plant separates carbon fixation from the rest of the Calvin cycle.